Hello students, today we will solve a question, and the question says like, calculate the potential at point P due to the charge of 4 into 10 to the power minus 7 coulombs located 9 meter away. This is the part A, and the part B says, hence obtain the work done in bringing the charge of 2 into 10 to the power minus 9 coulomb from infinity to point P. Does the answer depend on the path along which the charge is brought? So in the first case, we are given that we are having a charge Q of 4 into 10 to the power minus 7 coulombs magnitude, and it is located 9 meter away. We have to calculate the point P. Like, this is our point P, and here is our charge Q. So the distance between the two is 9 centimeter. We have to calculate the potential at point P. Potential at point P is to be calculated. And what is the magnitude of capital Q charge? It is 4 into 10 to the power minus 7 coulomb. So given is 4 into 10 to the power minus 7 coulomb charge, distance is 9 centimeter, and the potential's formula is given as V equals to Q into 4 pi epsilon naught into R square due to charge Q. Due to charge Q, we will substitute the value. We know that 4 pi epsilon into naught equals to K. K is a constant and its numeral value is 9 into 10 to the power 9. So we will substitute the value. 1 by 4 pi epsilon naught is 9 into 10 to the power 9 into charge's value is 4 into 10 to the power minus 7, and the distance is given as 9 into 10 to the power minus 2 whole squared. Why 9 into 10 to the power minus 2 is here? R is given is in centimeters. Now this centimeter R is converted into the meter. To convert it into the meter, we know that 1 meter equals to 100 centimeter. Therefore 9 centimeter will be equals to x meter. Now cross multiplying it, 9 equals to 100 into x, and x will come 9 divided by 100. So it can be written as 9 into 10 to the power minus 2, or it can be written as 0.09 meter. Okay, so any of the values is correct. Substituting the value in meter, always make sure whenever you are solving a question in physics or chemistry, you convert all the SI units, like units, into SI units. Degree centigrade should be converted into Kelvin, or distance should be into meter, time should be into seconds, and there should not be any degrees. Instead of degree there should be radians. Okay, and other than that, gram is not a SI unit, kg is a SI unit. Any other basic unit which you remember, you can make a chart of it, and always make sure that you are using these SI unit instead of the general unit given in the question. If you are using these general units in the question, you may get a wrong answer. So make sure that you are not doing such silly mistakes. Now after substituting all these values and after solving it, we received potential as 4 into 10 to the power 4 volts. One of the SI unit for the potential is volts. Now this is our answer for the first question. In the second part of the same question is, hence obtain the work done. Now they are asking us to obtain the work done for the given potential, and for finding the work done we are bringing a charge of 2 into 10 to the power 9 minus 9 coulomb from infinity to the point capital P. So here test charge Qt is given by 2 into 10 to the power minus 9 coulomb, and it is being brought from infinity to point P. Now what is the amount of work done? Work done is given by charge into potential. Work done equals to charge into potential. So charge is given in the question. The value for this is given in the question. And for the V we have found in the part 1. Value found in part 1. Now this is it. We are multiplying it, and the work done, amount of work done we received is 8 into 10 to the power 8 into 10 to the power minus 5 joules. So the other, in the B part itself, the second line, it was asking us, will this work done will depend on the path followed by Qt to come from infinity to point P. We have read in the introduction part of our chapter 2 that work done is a path independent quantity. So the work done will not depend upon the path followed by Qt to come from infinity to point P. So the answer will be no. Work done is a path independent. Now any arbitrary infinitesimal small path can be resolved into two perpendicular displacements, alone R and another perpendicular to R. Work done corresponding to the later will be 0. So what this means is that we have seen in the vector format, like this is our path of charge. Now along this there is one displacement, and along at 90° there is another displacement. So this is our R. Along this it is making a theta angle, and around this it is making 90 minus theta angle. Now this is defined as R cos theta, and this is defined as IR sin theta. So most of the time this perpendicular component, perpendicular displacement component gets cancelled out. Hence its resultant will always comes around to be 0. So most of the time what is followed is the component along the vector R. Component along the displacement vector R. So hopefully you have understood the question. You understood how to find the potential. It is found like epsilon into R square, and how to find the work done with the given potential. So these are the two formulas we have used in our question, and make a note of this and try to solve the question by yourself, and try to solve question which are similar to this to have a better clarity. So that's all for today's class. We'll come with a new question in the next class. So bye bye. Have a good day.